All right, number 1. How did you attempt this?
I distributed negative squared power to the top.
Some might try u substitution. What would be the u that you would try? X cubed plus 5, and that would allow du to get me the x squared that I need. The problem is, I'm going to go through it to make sure you guys understand why. I'm going to divide by 3x squared, so 1 over 3x squared du equals dx. When I go to substitute in, I get u over x squared times 1 over 3x squared du. And that doesn't cancel out your x squareds, that just compounds the issue, right? So u substitution actually will not work on this. If you tried making u x squared, that might have worked, except for when you take the derivative of x squared, you get 2x, and that doesn't get rid of the x cubed, it only gets rid of one of the x's. So that's not going to work. So now what did you do? Move it outside. What? So you said x to the negative 2 times x cubed plus 5? And then did what from there? Okay, I guess you could look at it that way. So x to the negative 2 times x to the 5th is x plus 5x to the negative 2 dx. Okay, that's one way of looking at it. I didn't look at it that way. I took it and I just divided. So x cubed plus 5 over x. You can distribute the divisions. You get x squared plus 5 over x.
That's a square.
Sorry, that's a squared here?
Yeah.
So I get x plus 5 over, I can't write, 5 over x squared. It's the same thing, but it's just a matter of how you get there. So what is the antiderivative of x? 1 over 2x squared. The antiderivative of this? It's going to be x to the negative 1, and then this will be negative 5, because we're taking the 5 and dividing it by the new coefficient, and then plus c. So 1 over 2 x squared minus 5 over x plus c. So it is c, but you all know that because you cheated. But, you know, whatever. Number 2. What table did I give you? I gave you position, and I'm asking for velocity at t equals 3. Now, be careful with this, okay? If I want to find velocity, what would I do? Find the what? Find the slope, find the average slope. Well, if I find the average slope between 2 and 4, I know the slope at 3 might be reasonably close to that. But here's the key. It says that the graph of the position function is increasing. If position is increasing, what does that mean for velocity? Okay, and if the graph of the position is concave up, then velocity is increasing. So I want to look at a progression. I want to see velocity increasing. So I don't care what's going on from 2 to 4. I care about what's going on in increments. So let's go ahead and find the slope between 2 and 3. What's the slope between 2 and 3? 92 minus 55 over 3 minus 2, which is what? 37. Now this is the velocity somewhere between 2 and 3. What's that called? What? Yes, but what's the theorem? The mean value theorem, because we're finding slope, right? The mean value theorem states that the average slope from 2 to 3 will be this somewhere between 2 and 3. Now, if the slope between 2 and 3 is 37, what does that tell us about the slope at 3? It has to be higher than that because it says position is concave up, therefore the slope is increasing. So let's find the other slope between 3 and 4. 150 minus 92 over 4 minus 3, which is what? 58. So we would say the slope has to be between those two if I want to see the slope increasing, if I want to see the velocity increasing. So the only possible answer that makes sense is B. You guys okay with that?